Okay, so let's recap our important ideas for what we've done so far. So we've done two other sampling methods today. We did a cluster, which is when we took each of the columns. So basically with cluster sample, the formal definition here is you take your whole population, you take everybody and you split it into sections. Each section in our case was based on a column, which gave us full spread of all the locations from front to back of the seating. And then you do have to randomly sample a group. Another great example of this is stadium seating. So if you're looking at like a sporting event and want to figure out how much people pay per ticket or something, you basically want to represent all of the characteristics of whatever the population is in a group. So like in a stadium, you could pick a whole section randomly because that would get people from bottom to top. If I wanted to do it for a school, it would be something like I'd have to represent every grade. So if we had like homerooms or something instead of advisory where there's mixed grade classes and I have 9, 10, 11, and 12 all represented, that would be a cluster I could pick. So you're taking the whole population and breaking it into mini populations, little mini samples that still have like all those characteristics. So the difference between a cluster and a stratified sample, a cluster, you have heterogeneous groups, which means there's mixed groups, mixed characteristics. Strata are homogeneous groups. So there's something about the strata or the group where one characteristic is all the same. So that could be like in high school, a strata could be a grade. So maybe I randomly pick from each grade to guarantee that I get a little bit of everybody in my group. So that's a big difference between cluster and stratified. Systematic random sample is when you're randomly, again, choosing a starting point and then counting a certain number of things between each of the things you're picking. So in the formal definition here is that we're sampling with an equal interval between each of our individuals. So each thing we're picking, there's equal space between those that we're choosing. So in this case, when we're picking seats, that works pretty well to do that kind of method. So some of the benefits to summarize: a simple random sample will always be unbiased because you're randomly picking, everybody has an equal chance of being chosen. Stratified typically will give you lower variability if there's some sort of characteristic that you want to make sure you're accounting for. And it's also unbiased because it is also, again, random. Cluster is just honestly is also unbiased, but it's a really easy one to take because if you just have things already grouped and you just pick a couple of groups and that's your sample, that's a lot easier to do sometimes. So like I said, stadium seating and stadiums, when you have a huge population, clusters have a pretty big benefit as long as you're randomly picking the clusters. And then systematic, you don't need to label everyone. So you just have to pick a starting point and then start counting. So that's also another like easier one, but that's also unbiased because you're doing a random starting point. So in terms of what we want to see in a sampling distribution or like our dot plot that we get after, is basically something with low variability and low bias. So wherever we think our true value is, like for the whole shebang, the whole population, we want to be centered over that, and we want to have like compact data. We don't want the data all over the place. So this is kind of the ideal picture. Anything that's biased, again, is not centered over where it should be. So if you're doing a convenience sample or not a random method, that's going to be biased usually. Sometimes they have low variability, which is nice, but they're kind of centered where they should not be. So it doesn't give us a good estimate of what the true value is. And then for these are really what we don't want. So they're all over the place and they're not accurate. So that they're very, very biased or skewed. This one's kind of skewed. This one's just all over the place. But it's sort of centered where it should be, but it's again like just kind of the data's all over, which isn't very accurate. So kind of think of it like accuracy and precision, same kind of idea. So those are our important ideas for all of our sampling methods that we've done up to now.